In the earlier video, we have seen the two properties, uniqueness of identity and uniqueness of inverse of a group. Now the third property is cancellation law. So in a group G, if A operation B is equal to A operation C, then B is equal to C. This law is known as left cancellation law. And if B operation A is equal to C operation A, then also B is equal to C. This law is known as right cancellation law. So if we want to prove the first one, that is A operation B is equal to A operation C is equal to B is equal to C, then if we pre-multiply the above equation by A inverse, so we will get A inverse operation A operation B. By applying associative law, we will get A inverse operation A, that is identity element. So in the left hand side, we will get B. Similarly, in the right hand side, if we pre-multiply by A inverse, we will get A inverse operation A operation C. Again, by associative law, we will get A inverse operation A together, operation C. A inverse operation A becomes E identity and E operation C becomes C. So in the right hand side, we will get C. So B is equal to C. This is the left cancellation law. And for proving the right cancellation law, just post multiply the equation B operation A is equal to C operation A by A inverse. In the similar manner, you will get B is equal to C. This law is known as right cancellation. And the fourth property is existence and uniqueness of solution. So in a group G, there exists unique solution of the equation A operation x is equal to B and y operation A is equal to B. Again, for going to the proof of the first one, that is A operation x is equal to B, if we pre-multiply this equation by A inverse, again we will get A inverse operation A operation x is equal to A inverse operation B. So A inverse operation A by using associative law, we will take these two elements as together. So A inverse operation A is equal to E operation x is equal to x. So in the left hand side we will get x and in the right hand side we will get A inverse operation B. So x is equal to A inverse operation B. Now by property of group, by the definition of group, we will know that if A belongs to G, then A inverse belongs to G and B is an element of G. So A inverse operation B by closure law is also the member of G. So x is equal to A inverse operation B is a solution of the given equation. Similarly, for finding the solution of y operation A is equal to B, just post multiply by A inverse, we will get y is equal to B operation A inverse, and the similar manner we will get that this element belongs to G. So y is equal to B operation A inverse is the solution of the equation y operation A is equal to B. Now to show that these solutions are unique, let us consider that there are two different solutions, x1 and x2 of equation 1. So if x1 and x2 are the solution, then we will get A operation x1 is equal to B, and if x2 is the solution, we will get A operation x2 is equal to B. Now, because both are equal to B, we can write A operation x1 is equal to A operation x2, and by left cancellation law, we will get x1 is equal to x2. That means x1 and x2 are not the two different solutions; they are the same solutions. Similarly, if we take y1 and y2 be the two solutions of y operation A is equal to B, then in the similar manner we will get y1 is equal to y2. So the solution is unique. So in a group